1 by 2, 1 by 2, 1 by 2, 1 by 2, 1 by 2 will get 5 by 2, 5 by 2, 14 plus. Hello students, welcome back to today's class on perimeter and area. In the last class we have discussed about perimeter and. Hello students, welcome back to today's class on perimeter and area. In the last class we have discussed about perimeter and some applications based on that, and we just started area. So let's try to continue our discussion with area and its applications, right? My name is Avinash and I'm a graduate from IIT Kharagpur. Let's start today's session. So what is a perimeter? We have already discussed in the last class, right? So that is a complete boundary. The complete boundary of the given figure. But now let's try to discuss about area. In this figure, okay, so whatever the amount of surface enclosed. What do you mean by enclosed? Enclosed means the area inside. Enclosed means the area inside, whatever the area inside, whatever the space inside, so that is called enclosed, right? The amount of surface enclosed by closed figure is called its area. Here this is a square, and the area of a square is the complete all these points, or all the complete space, complete surface. Okay, for example, you have a rectangle or you have a triangle. So for triangle, this complete space is the area of that polygon. Area of that polygon. Even for circle also there is an area. Even for circle also, as a closed figure, you have the shaded thing which has some surface, so we can say that it is having an area, right? So now the major questions are how to find or how to calculate the area of a given figure. So let's try to understand that more about. So to calculate the area using a squared paper. What do you mean by squared paper? Squared paper means it has unit squares in that. It has unit squares in that, right? So this is one square, one unit square. Like 1 unit means 1 centimeter, let's say. 1 centimeter, that's a square. Okay, you have one more square, So the complete paper is squares. So based on that squares, if we take one box as 1 square unit, so from there we can try to find the area, right? So let's try to take one example. So if more than half a square is in the region, count it as 1 square unit. For example, I am going to find the area of this figure. The area of this figure, you can see this, right? So the area of this brown figure enclosed. So now we need to find all the squares. How many squares are there? Let me see that. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. So 14 full length squares are there. 14 full length, that means the complete square is there. But the rest of the things, you can see it's exactly passing to the mid, which is actually half. 14 plus half, this is half box, this is also half, okay, plus half, this is one more, 2 and 3, more 3 times, right? Plus half, plus half, plus half. Once again, let me see what all the half boxes we are having. 1, 2, 3, 4, 5, right? So 14 plus 1 by 2, 1 by 2, 1 by 2, 1 by 2, 1 by 2 will get 5 by 2, 5 by 2. 14 plus 5 by 2, which is 14 plus 2.5, which is 16.5, right? 14 plus 2.5, 16.5. The area we should always use as square units. So answer is 16.5 square units. 16.5 square units. So that is the area of this figure. But not always the boxes are exactly half. Sometimes we may not have the complete box if more than half a square is in the region, right? In the same figure, let's say we have one more box that is included, and which is more than half, right? So even let's say this part is included. This part is included. You can see this. It is a more than half. Half means exactly in the middle. But here it is not exactly in the middle. More than half. Then we can count it as a 1 square unit. we can count that as 1 square unit, right? So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, then 14. 14, 14.5, 15, 15.5, 16, 16.5 plus 1 complete thing is coming here. So that will give you 16.5 plus 1, which is 17.5. 17.5 area is always a square units. Area is always a square units. 16.5 plus 1 will give us 17.5 square units, correct? Okay, so moving ahead for the next concept, if exactly half the square is covered, just now we discussed, if exactly half is covered, count it as a half square unit. So exactly same thing, 1, 2, 3, 4, 5, all these are exactly half. You can see the diagram carefully. In that case, you can include half. 1, 2, 3, 4, 5. There are 5 half square units. There are 5 half square units, correct? Okay. So moving ahead, if less than half a square is in the region, if less than half, that means in the same triangle, the same figure, we have one more box which is actually something like this. Okay, this small part. So now you want to add this as 1 square unit, but you cannot. As it is less than half, as that region is less than half, we say that it is considered as 0. Do not consider the region. Do not consider. So now you may ask me, sir, is this the exact area? No, these are the approximations. These are the approximations where near to the answer, near to the actual answers, correct? Okay. Next one. Right, so we need to find the area of this figure. Let's say each and every box is a 1 square unit. So we have 1, 2, 3 and 4. So total 4 square units plus, total 4 square units plus, it is exactly half, half, half and half. So we have total 4 halves. 4 into half, right? So 4 plus 2 1s to 2s. So 4 plus 2 is 6. 4 plus 4 into 1 by 2, that becomes 4 plus 2, which is 6. But area, I said you, area has some units, 6 square units. 6 square units, correct? Alright, next one. Find the area of the figure below. Okay, so here this is the figure. So I'll draw it once again. So this is one part, next line, the next line, again the next line, and again from the starting, right? So this is how the given figure is there. We need to find the area. First of all, try to bring all the perfect squares. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So answer should be 12 centimeters square. Answer should be 12 centimeters square. Okay. Find the area of the figure. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So the complete area is 12 centimeters square. Okay, next one. Find the area of the figure. Okay, we have one more figure. Let me draw that properly. So this is one side, second, third side, fourth, 5, 6, and 7, and this is 8. This is an octagon. What do we say? This is called as octagon. Octagon means 8-sided polygon. 8-sided closed figure, right? So now to find the area, first of all, find how many perfect squares are available. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Right? Anything else more? Maybe this one also, maybe 11. Okay, we don't have any part here. This is also a part here. Okay, so 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 and 11, 12. So till here we got 12. We got 12 centimeter, 12 units, 12 square units. But this is exactly half, and this is exactly half. Half 1 by 2, 1 by 2. This is 1 by 2 again. This 1 by 2 again. This 1 by 2 again, and 1 by 2. So how many 1 by 2 schemes? 1, 2, 3, 4, 5, 6. So that becomes 12 plus 6 times of 1 by 2. So 2 1s to 3s. So 12 plus 3 will give you 15 square units. 12 plus 3 will give you 15 square units. Once again, let me check that. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14 and 15. Right, 15 square units is the area of the given figure. All these are approximately correct. Okay, not exactly. Next, find the area of the figure below. Now what happened? All that is a square, all that is a circle. Don't worry about that. Just concentrate on the squares. Okay, so here we have 1, 2, 3, 4 and 4 I'm sorry, 4 perfect squares plus this is more than half, include 1, more than half, include 1, less than 1, delete, less than half, not less than 1, less than half, delete, right? It is included, included, right? So all these are included. Okay, again at the corner. Okay, so find the area. So this is again less than half, this again less than half, so this part and this part cannot be added. These two parts cannot be added. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, right? So that becomes a 12 square units. So that becomes a 12 square units. Let me check that again. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, right? So that's it. Yes. So the rest of the things which are very less than half will not be included them. Okay, the next one. So formula for finding the area of rectangle. Area of rectangle is length into breadth. Don't confuse with the perimeter. Perimeter is equal to 2 times of length plus breadth. Perimeter is equal to 2 times of length plus breadth. But here, the formula of area of rectangle. Area of a rectangle is length into breadth. This is length, this is breadth. So that becomes length into breadth. Okay. L is the length of the rectangle. L is length of the rectangle and B is the breadth of the rectangle. L is the length and B is the breadth. Okay. Now let's try to move ahead. Let's try to say if this is 4 centimeters and this is 5 centimeters. Okay. This let's say this is 40 centimeters and this is 5 centimeters. 40 centimeters and 5 centimeters. How to find the area? Area is length into breadth. Correct? Area is equal to length into breadth. So 5 4s are 20. So that becomes 200. Area is equal to 200. 200 always units. If you're not clear, just write a square units. It may be centimeters, it may not be. Sometimes in the equation it may be mentioned, it may not be mentioned, but still we need to write that as 200 square units. 200 square units, correct? Right. Let's move forward for the next one. Find the area of the given rectangle. Find the area of the given rectangle. So 2 times of perimeter. If you go for perimeter, it's 2 times of length plus breadth. So 2 times of 7 plus 5. So 2 times of 7 plus 5 is 12. That is 24. Even the perimeter is 24. But now we need to find the area, right? So area is like length into breadth. 7 into 5. 7 to 5 is 35 centimeters square units. Square units. 7 into 5 is 35 square units. Okay. So moving ahead. The length of a rectangular field. So we have a question, some applications based on all this. Let's try to understand that. The length of a rectangular field is 60 meters. Length is given as 60 meters. And the breadth is given as half of its length. Breadth is equal to half of its length, 50. Right? 50 meters. 60 meters and 50 meters. Find the area of the field. The breadth is half of its length. So once again, let me check that. Length of rectangular field is 60 meters. And the breadth is half. Half means not 50. I'm so sorry. Half means half of the length, which is half of 60. Which is half of 60, which is 2 1s to 3s. So that becomes 30 meters. Length is 60 meters and breadth is 30 meters. Find the area of the field. So I told you for rectangle, the area will be always simple. Area is equal to length into breadth. So length 60 into breadth is 30 meters square. 30 meters. So now in the area we need to keep meters square. So 6 3s are 18. 1 2. So that becomes 1800 centimeters square to press. Okay. So L is equal to 60 meters, B is equal to 30 meters, A is equal to length and breadth. 60 and 30, 1800 centimeters square. Area of this rectangle is equal to 1800 centimeters square. Okay. Half of its length, you need to understand this statement. Half of its length, that is half of the 60. Half of the 60 is 30 meters. So if this is clear, you can solve the remaining question. Okay. So the next one. Find the area of rectangle whose length is 4 meters and breadth is 68 centimeters. Once again, see here 60 meters and half of it. No problem. Okay, and 60 meters, so answer is 1800 meters square. But here it was given as find the area of rectangle whose length is 4 meters. The length is 4 meters and breadth is 68 centimeters. So either we need to convert both into lengths, both into meters or both into centimeters, right? So find the area of rectangle whose length is 4 meters. Length is 4 meters or 4 into 100 centimeters. So that will give you 400 centimeters. That will give you 400 centimeters and breadth is equal to 68 centimeters. Breadth is equal to 68 centimeters. So now, if it is asked for perimeter, you can directly go with 2 times of length plus breadth. You can directly go with 2 times of length plus breadth. But now, it was given with area. Area. So you need to find length into breadth 400 into 68. 400 into 68. Or, you can also do in another way. You can keep length as well as it is 4 meters. 68 centimeters is 0.68 meters. So meter into meter, you will get meter square, or you get here centimeter square. Okay. So 68 fours, let me check that. 68 fours, 8 fours are 32, 6 fours are 24, 26 24, 25, 26, 27, 272, and yeah. So 68 into 4, 272, and we have 2 zeros. So that becomes centimeter square. 27200 centimeter square. Or if you want to convert into meters, you need to do a lot. Let me tell you why. Because this is also in centimeters, this is also in centimeters. Both you need to convert into meters, right? So here 0.68 into 4. 8 fours 32, 6 fours 6 fours are 24, 25, 26, 27, 4 0 0 and 2. That becomes 2.72. 2.72, that becomes a 2.72 meters square. You need to divide with not just 100. You need to divide with 100 into 100 because we have centimeter square. Centimeter square gives that it is a centimeter into centimeter. Here for meters, you need to divide with total not 100 with 100 into 100. That is at 10,000. Okay. So moving ahead, the area of rectangular garden which has 40 meters length. Length is 40 meters and the area is given as 1120 square meters. 1120 square meters or meter square, whatever it is. Find the width of the garden. So we know that area is given as length into breadth is equal to the area, whatever you get, 1120. So length is 40 meters, right? 40 into B is equal to 1120. So B is equal to 1120 by 40. So now we need to divide. 4 and 4 gets cancelled. So 4 and 112. 4 and 112. For 3s are for 3s are for 2s are 4 2s are 8. We'll get 3 2, and for 8s 8 4s are 32. So that we can keep 28. 112 by 4 breadth, 112 by 4, which is a 28 meters. So length being 40 meters, breadth being 28 meters, you will get the total area is 1120 square meters. Okay, so let's try to move forward to the next question. The area of rectangular plot is 2400 square meters. So area is given as 2400 meters square and its length is given as 1.5 times. And its length is given as 1.5 times to its breadth. 1.5 times to its breadth. So what is the perimeter? So a very simple question. I'm not going to do this now. Okay. Once again, let's try to discuss. The area of rectangle is given. Area is equal to length into breadth. Length into breadth is equal to 2400. Right. So length is 3 by 2 into breadth is equal to 2400. So you can calculate from here what is the perimeter. What is the what is the breadth from the breadth? We need to go back to perimeter, right? So length 3 by 2. It's not actually 3 by 2. 3 by 2 times 1.5 times its breadth. Let me calculate that once again. Let me bring the correct calculations here. Right. Okay. So length is 1.5 times breadth. So breadth is there. B is B but length will give you 1.5 times of B. So 2 ones 2 plus 1, 3 by 2 times of B. 3 by 2 times of B. So now length into breadth, because the area is given 2400, length into breadth is equal to length into breadth is equal to 2400. Okay, so you can cancel with 3. 3 ones 3 12s, 3 ones 3 12s, that becomes not 12, 3 8s. Sorry, I'm cancelling with the 2. Cancel with 2. Let me erase that. Right, so 3 by 2 into B, that becomes area, that becomes 2400. So 3 and 3 8s, so 800. 3 and 800, right? So what about here? B into B is equal to 800 into 2, so which is 1600. Breadth into breadth is 1600, so we'll get it is actually equal to 40 into 40. We'll get it as 40 into 40. It is enough to say that the breadth is 40 meters. Breadth is 40 meters. From there you can try to find 1.5 times, which is the length. From there, if you multiply these two, you'll get the area. And sometimes mistakes do happen. I'm saying again, sometimes mistakes do happen. Just please cross check all this and then we can move forward, right? So there are a couple of more applications based on this perimeter and area, which we are going to cover in the next class, right? Thank you so much, friends. Stay tuned to get the next lecture. Thank you.
Yeah. Hello everyone. So today we will be discussing about rest and motion. That is, we will be starting with a new chapter, motion. Okay. We will be learning about motion, that is how bodies move. We will be learning about distance, displacement, speed and velocity. I think many of you might already know what distance and speed are. We use that every day in our daily life. Yes or no? So we will be learning about distance, speed, as well as about other terms, new terms for us, displacement and velocity also. Okay, we'll also be learning about other topics also. We'll go into them one by one. Okay, so my name is Shashin Reddy. I'm a graduate from IIT Dhanbad. So let's start the class. In today's class, these are the topics that we'll be learning. We'll be learning about rest and motion, and we'll be learning about types of motion. Right, we'll go into that. So first, let's talk about rest. So look at these images. So we know what rest is. So we can clearly say that this table is at rest. This book is at rest. Here, the mountains are at rest, the trees are at rest, and this bench is at rest. The question is, how do you define rest in that case? How do you define rest in that case? Yeah, some of you might be saying this, sir, if any body does not move, if any body is not moving, then we say that the object is at rest. Good enough, simple definition, right? But when an object moves, what happens? Its location changes, its position changes, yes or no? That means when I talk about rest, rest is a specific case where, or else you can say body is said to be at rest. Just a minute. A body is said to be at rest when its position with respect to its surroundings, when its position does not change with time. Its position does not change with time. It is there itself. It is not moving. Right? So when you say, sir, rest will mean the object is not moving, you are correct. But the exact scientific, technical definition would be that an object is said to be at rest when its position does not change with time, or position with respect to its surroundings. When we say with respect to position for its surroundings does not change with time, yes or no? You can clearly see that the book is at rest. It is not moving when compared to the table. Table and the book are at rest. The mountains, the trees, the road, the grass, the chair, not the chair, the bench, all of them are at rest. So this is about rest. Now when we define motion, or when can we say body is in motion then? We defined when a body is at rest. So when can a body be in motion? You know the answer. That is when its position changes with time. Position does not change with time, rest. When position changes with the time, the body is said to be in motion. So that's what we're talking about. A body is said to be in motion when its position changes with time. A simple example, you can see a cheetah here. Can you see a cheetah, everyone? That's not a cheetah, right? That's a tiger. And you can clearly see a tiger, and that tiger is running. It's moving. And how can we say it's moving? Because its position changes. Its position is changing. It is moving. And here you can see a rocket launch. Can you see a rocket launch here? Yes. On the left side of the screen, can you see a rocket launch? Yes, you can see a rocket launch. And that rocket is moving because its position is changing. Its position is changing. Got it? And again, now you understood what motion is. Now at times, you can look at this here. A very interesting animation. Or you can look at this. This is what you notice or what everyone of us would have noticed. Whenever you're traveling, let's say you're in a car, you're in a train, you're in a bus, or you're on a bike, or on a cycle, anywhere, you're traveling. And if you look outside the window, let's say you're in a car, you're sitting in a car, the car is moving, and you're looking outside the window, you can see the trees going back. Can you see that in the animation? You can see that the trees are going back. But if you notice that the car does not appear to move. What appears to move is the trees are appearing to go back. So you are inside a car. We'll discuss about this in this way. I'll say there are two people. Let's say Ram is in the car. Ram is in car. And Ram is going towards right. The car is going towards right on the road, and there is a tree. There's a tree beside the road. Okay, there's a tree beside the road. Now, and I'll take another person here, standing outside. I mean, just standing outside. So let's say here, I'll take Raju. So Ram and Raju. Ram is in the car. Raju is outside. Yes or no? So for Ram, what happens? It's like this. For Ram, what does Ram see? Ram will see this. What does Ram see? Ram will see tree going back. Ram sees tree going back. Yes or no? I'll write that down. For Ram, tree appears to go back. Tree appears to move back. Yes or no? Because his car is going front. But for Raju, what happens? For Raju, the tree is not moving. Or I can say the tree is at rest for Raju. Yes or no? Yes or no? So you can see Ram and Raju. For Ram, the same tree is moving back. For Raju, the tree is at rest. What can you say? This means that an object here, let's say, think of it as a tree. An object can be at rest or can be at motion, the same object. It depends on what? Depends on who is seeing the object. Who is seeing the object? So for Ram, it's moving back. For Raju, it is at rest. That comes back. I mean, that gets us back to this simple statement. Rest and motion are relative. What does relative mean? It depends on who is watching the object, who is seeing the object. Got it? And another interesting animation here, when you are in a train, you can see people are in a train. Right, so there is a camera recording, right? And you can see the buildings are going back. The buildings are going back. You will not feel that train is going forward. No. You will feel that the buildings are going back. But do the buildings actually move? The buildings don't. We move. Okay, that is the reason. So rest and motion are related. Now another interesting example we have. What is that? We'll discuss about that. Look at this. Look at the left image, everyone. You can see a girl who is comfortably sitting on a sofa and reading a book. So if I ask you, is the girl at rest or in motion? What will you say? You can say that the girl is at rest. Generally, the girl is just sitting, so girl is at rest. I'll write that down. Girl at rest. But if you ask the same question to sun, I'm asking the question to sun, can you see the girl? Sun will say, yes, I can see the girl. Sun is powerful. So the sun, if I ask the same question to sun, is the girl at rest? What will sun say? What will the sun say? I mean, if you ask the sun, is the girl at rest? What will the sun say? The sun will say, the girl is not at rest because see, the girl is on earth. And earth itself is moving. Now the girl will also move along with the earth. Girl will also move along with the earth. So for sun, the girl is at rest. Okay. So I'm standing here. I'm just standing here. Am I at rest? For you, I am at rest. I am just standing. But for sun, I am moving. For sun, I am moving along with the earth. Earth is moving. So along with earth, I have to move. In fact, all of you should be moving. Another interesting example of what? Rest and motion are relative. So an object can be in motion relative to one set of objects, one type of objects, while at rest relative to some other set of objects, some other type of objects. Example, as you can see, you are at rest with respect to your room. Okay, comfortable. But with respect to sun, you are in motion as the earth is revolving. Clear? Understood? So the same simple statement is this. Rest and motion are relative. It depends on who is seeing, who is watching it, who is observing it. That's why we call them as relative. Rest and motion are relative. Clear? Okay. Okay, that's enough about rest and motion. Let's continue forward. Now we'll talk about the types of motion. So what different types are we discussing about? We'll discuss about a few types that I have listed them down here. We'll start discussing about all of them: translational, circular, rotational, oscillatory motion, periodic motion, and it should be non-periodic motion, and then we'll also be discussing about random motion. Okay, completely random motion. We'll be discussing about all of them. Let's go into them one by one. So here, look at this. Look at a car. A car is moving. Very simple case. A car is moving. Now when you look at this car, I'll just take a slide. Let's say the same car has gone from this position to that position. It has gone from start position to end position. I'll ask a simple question. I'll ask a very simple question. The front end of the car has moved by how much? Let's say it's moved by 1 kilometer. The front end of the car has moved by 1 kilometer. The question that I'm asking you is, by what distance did the back end of the car move? If the front end of the car has moved by 1 kilometer, by what distance will the back of the car move? Yeah, everyone. Very simple. Very, very, very simple. So what would that be? That will also be 1 kilometer. Yes, absolutely correct. So both the front end and the back end has moved by 1 kilometer. Very simple. Right, and this type of motion is translational. What is this? That should happen always. It doesn't happen always. We'll discuss about when it doesn't happen. I'll go into that. But this type of motion where an object moves in such a way that each point of the object moves the same distance. That's an interesting point. The object moves, each point of the object moves the same distance is called as which motion? Translational motion. For example, a car moving on a straight road. A car moving, the motion of a car. Simple. Because you can clearly see the front end moves 1 kilometer, the back end also moves 1 kilometer. Understood? Okay. Now we have two types of translational. One is rectilinear and the other is curvilinear. Now what are they? I'll explain to you. First of all, linear will mean line. Now when we say rectilinear motion, recti will mean a straight line. So along a straight line, So the motion along a straight line, motion on a straight line is called rectilinear motion. Curvilinear, a curved line, that's it. Motion along a curved line. We'll go into them. So let's go into rectilinear. A very simple example you can clearly see here. If you drop a ball, not only a ball, any object, not feather by the way, any heavy object, let's say. So if I drop this pencil, I'm not dropping it by the way, okay. If I drop the pencil, if I drop the remote or any object, if I have a ball, if I just drop it, what will happen? It will fall down. And when it falls down, it goes along a straight line, yes or no? It goes along a straight line. So that is one simple and classic example of what? Classic example of motion along a straight line. Motion along a straight line, it's called as what? Rectilinear motion. Motion along a straight line is called as what? Rectilinear. Sometimes it's called as linear motion. But exactly speaking, it is rectilinear. And coming back, it is also a type of translational motion. Because again, see, this is the ball. This is the ball. If the front end, let's say, falls down by 2 meters, how much does the back end fall? The back end will also fall down by 2 meters. So every point on the ball moves the same distance, 2 meters and 2 meters. That is the reason why it's called as what? Translational motion. And rectilinear is a type of translational motion. That's it. Understood? Okay. Now curvilinear path. It's in the name itself. It is motion along a curve. You can see a person just throwing a ball. It's a cricketer, right? A cricketer just throwing a ball. The ball, the motion, the path will be a curve. Yes or no? The curve. But again, if you talk about the distance moved, every point would have moved the same distance. So a curvilinear. And when a car goes along a curve, its car is taking a turn. In that case also what happens? The front end moves by 1 kilometer. The back end will also move by 1 kilometer. So every point on the car or of the car will move by the same distance. Translational motion. The path is a curve. When I say curve, it can be a circle or it can be anything else. A simple curve. Okay. This is also a curve. Curvilinear path. Okay. So that is curvilinear and it is also a type of translational motion. Understood? Okay. Let's go into a simple question then. Which of the following is undergoing curvilinear motion? Cyclist taking a turn on the road, coin moving on a carom board, object dropped from a height, or all of the above. What is that going to be? Let's take 30 seconds of time. Should be enough. Yes or no? So what is the correct answer? Yeah, everyone, please think about it. What is the correct answer in this case? Which of the following is undergoing curvilinear motion? 20 seconds of time, so please do it. The time is up. That means the bell has rung, and when the bell rings, the time is up. So here, by the way, the answer is obviously option A. Cyclist taking a turn. When you take a turn, it is not a straight road, it is a curved road, so curvilinear. Simple example. Coin moving on a carom board, coin goes along a straight line. Object dropped from a height, straight line. So B and C are rectilinear. But we need curvilinear, so option A. Understood? Okay, let's continue. Now look at this. Now this is again a special type. The circular motion we are talking about. What is circular motion? Look at the left animation. You can see a blue color dot moving, yes or no? And it's going along a particular path. And that path is what? That path is a circle. It is what? It's a circle. So whenever an object goes along a circle, along a circular path, it is called as circular motion. You can clearly see here, or else you can see on the right animation here, you can see a car going round, round, round. Yes or no? Round is like a circle, right? It's going round. It's going on a circular path. Continuously going on a circular path. So it is what? A circular motion. Understood? So motion of a body along a circular path. And we'll go into this point, the interesting point about that, we'll go into that. Other examples of circular path, moon revolving around the earth. Circular motion. A boy rotating a stone in a circle. Circular motion. So wherever the path is a circle, it is circular motion. Wherever the path is a circle, the motion is said to be circular motion. Simple as that. Okay? Okay. Now, very important, we'll be learning about this, properties of a circle. So understand this, for every circle there is a point called as center. You can call it as C. Now what does center do? It's just a point. The specialty of a center is the distance of center from any point is the same. So you can say, I can take different points. I can say A here. A on the circle, B on the circle, C on the circle, not C, C we have taken for center, D on the circle, E on the circle. Now why only these four? You can take any others, yes, you can take here, F, you can take G, H, I, you can take K, L, M and O, any point, it's up to you. So here, the point is, the distance from center CA, if it is, let's say, for example, if it is 15 centimeter, then C2B will be 15 centimeter, C2I will be 15 centimeter, C2D will be 15 centimeter, C2E will be 15 centimeter, C2F will be 15 centimeter, C2G will be 15 centimeter, and C2H will also be 15 centimeter. What does this point mean? This means that every point on the circle will be at the same distance from a point, and what is that point called as? The center of circle. You can clearly see, right? Every point is at the same distance, 15 centimeter, 15 centimeter, 15 centimeter and all. And you know what that line is called, or what that distance is called as? It's called as radius. Some important terms of a circle that you have to understand. So what is radius here? It is the straight line. It is a straight line from the center of the circle to any point on the circle, like C to D. Anyone. So here all these lines, CA radius, I'll call it as capital R or small r, it's up to you, you can do it anything. CB radius, CD radius, CE radius, you can take here also. CF radius. That is a line joining the center and any point on the circle. That line is the radius. The length also is called as a radius, the same name. Radius, very important. Then the interesting point is every radius will be of same length as we discussed. We took an example also of 15 centimeter. All of them will be of 15 centimeter. Understood? Yes? Okay. Now when it comes to a circle, we learned about center, we learned about radius, we learned that all the radii are equal. Okay. Now here, look at a circle, this is a circle, okay, and this is the boundary. You can call it as a boundary, yes or no? Now what is the length of the boundary? If the question comes up is, what is the length of the circle or the boundary of circle? How do you find that? Now we know how to find out the length of irregular lines, or how do you do that? You take a thread, place that here, you can place it anywhere, here, anywhere. Place it here, then make sure that thread is on the boundary. Thread covers the complete boundary. Then break it, then straighten the thread and measure its length. Right, that's how you do it. That's the experimental method. But do we have a formula? Yes, we have a direct formula to find out the circumference, the total length of the boundary of a circle. How do we do that? There's a simple formula, we'll go into that. But before that, it is called as circumference. The boundary of the circle, this complete boundary is called as circumference, and complete length of the circle or circumference. How do we get that? We have a simple formula. What is that? 2 pi r. We discussed about pi when we discussed about area of a circle. We'll again discuss it now. What is pi? Pi is just a name. Pi is a constant. It's a constant. What does constant mean? Its value never changes. So pi is a constant whose value is 3.14, approximately 3.14, not exactly. Or you can say in fraction, 22 by 7. Fraction 22 by 7 and decimals 3.14. That's how it is. So pi is what? Pi is a constant. Clear? So it's a name. Who is Sheshin? Sheshin is me. Sheshin is just a name given to me. So similarly, pi is just a name given to 22 by 7 or the value 3.14. That's it. It's just a name of a constant. And that constant is important in the case of a circle. Okay, so remember that formula 2 pi r. I'll go into an example also, don't worry. But circumference is equal to 2 pi r. That's it, simple, done. And if I go with area, what is area equal to? Again, everyone, formula, area of a circle, pi r square. Area will mean this complete area, by the way. What I am shading here, that complete area, that's what we are talking about. And that area will be given by pi r square. And the value of pi is also clearly given here, 22 by 7 or 3.14. 22 by 7 or 3.14, okay? Let's go into one example. Do we have an example? Don't. I'll take an example, don't worry. So if I take a circle of, let's say, radius, I'll take the radius, okay, center, and I'll say, let's say radius is 10 centimeter. Now what does the circumference be? The circumference will be, formula, everyone, 2 pi r. You have to only remember the formula, from where the formula came and all, not required as of now. So 2 into pi, what is pi? 22 by 7. What is r? 10. Now we can do the calculation, okay. We obviously can do the calculation, but it will be how much? 440 by 7 centimeter. Simple, right? Yes? Okay. Now if I talk about the area, formula pi r square. What is pi? 22 by 7. What is radius? 10 centimeter. 10 into 10. So it's going to be 20. So 2200 by 7 centimeter square. That's it, as simple as that. 2200 by 7 centimeter square. Clear? Yes? There you have it. Okay? Okay. Now we'll go into other type of motions. We learned about circular motion. We learned about circles itself. Okay? Then we'll go into this. Rotational motion. Now when generally say fan is rotating. Okay? A fan is rotating. Or you can say earth rotates. Have you seen a globe? If you see a globe, if you rotate a globe, if you move a globe, it's rotation. Okay? Now what does that mean? Here, you can clearly see when the earth rotates, there is a fixed line. Or if we call it as a fixed axis. Now what is fixed in a fan, a table fan? This is a table fan. What is fixed? Here, at the center, everything is fixed. That's where you have fixed line. I mean, the line goes like this. Through the center it will go. It's a fixed axis. Yes or no? In fact, let's say if I just look at me, okay? I'm rotating this. I'm rotating my hand. Is anything fixed here when I am rotating it? Yeah? My elbow, near my elbow, it is fixed. My elbow is fixed. Everything else is moving. Right? So it's rotation. In rotation, what is the specialty? The specialty is it'll have a fixed point, a fixed axis. That's the thing. Okay? So motion about a fixed axis is called as what? Rotatory motion or rotational motion. Understood? So we have other examples also, as you can clearly see. These are some examples. A fan, right? Making a pot. Who was playing with this? We used to call it as Beyblade. Right? Beyblades. A sewing machine, right? All of them, you have a fixed axis everywhere. So all of them are what? Rotational motion. See, here you have fan. This is a fixed axis. It does not rotate. Here also the center you'll have the axis. Here also the center, Beyblade. And here what is this point? That is fixed. And everything else rotates. That is fixed. It's all fixed point. In fact, even a door, whenever you open a door or close a door, okay, you pull or push, open or close a door, when you see wherever the hinges are, there the door will not move. The door is fixed at the hinges. Door rotates and near the hinges you have a fixed axis. So notice it this time. Whenever you open a door or close a door, notice that. Okay, so door is also fixed at the hinges. Understood? So that's rotational motion. Clear? So let's go into a simple question. Is rotational motion a kind of translational motion? Yes or no? I'll give you 30 seconds of time again. So please tell me. Think about that. In fact, I'll give a simple example. You can think in terms of that elbow example I showed to you. Is rotational motion a kind of translational motion? What do you think? And 10 seconds more. 5, 4, 3, 2, and 1. The bell rang. The bell rings and the time is up. So here, is rotational motion a kind of translational motion? No. Why? Because what is the main characteristic of translational motion? In translational motion, every point should move the same distance. Now again look at my hand, everyone. I am opening it and closing it. Yes or no? So when I bring it up, is every point of my hand moving the same distance? Is every point of my hand moving the same distance? See, my finger is moving from here to here, like here to here, here to here. But my elbow is not moving. But if you take other points, they don't move the same distance. I'll show it to you here. This is what my fingers moved. The tip of finger. But here you see, the middle of hand does not move the same distance. The distance moved is not equal and the elbow is fixed. The distance moved by every point is not equal. Only when they are equal, we say that it is translational motion. They are not equal, so it is not a translational motion. The answer is no. I think I should be not cross, my mistake. The answer is what? The answer is no. Clear? Okay. Now I'll go into differences between rotational and circular. Very simple differences. Do not get confused much. In rotational, it rotates about a fixed axis. In circular, the complete body is going in a circle. No fixed axis in circular motion. No fixed axis in circular motion. Then rotational motion, it is not a type of translational. But when it comes to circular motion, look at this. If I take the example, I'll take the example of, I'll just show a simple example. We'll go back to circular example. Just a minute. Here, look at this. Look at the example of a car moving. Here, the front end of the car and the back end of the car move the same distance. It's going along a circle, yes or no? They are moving the same distance. So car moves the same distance here. That means car is in translational. And which motion is this? Circular motion. So circular motion is a good example or is a type of what is a type of translational motion. So it is also a type of curvilinear motion, a special type of curvilinear motion which is translatory or translational motion. Then you have other examples of rotational motion, spinning top, the Beyblade, and you have athlete running on a circular path. He goes on a circle, he or she runs on a circle, the circular path, circular motion. Understood? Simple differences between rotational and circular motion. Clear? Okay, let's continue further. Now we have oscillatory motion. It's an oscillation. It's a to and fro motion. That's it. Like you can see the swing here, right? Let's say the boy starts from here. Starts. It goes. The boy goes to another point, then comes back. Comes from it. So it's a to motion. If I say to A, this point is A. The boy is going to A and coming back from A. So to and fro. That's it. That is oscillation, right? So to and fro motion of a body from its rest position or mean position. What is the middle position is mean. Okay. But you can just say, you can forget about this, from its rest, not required. To and fro motion of a body. That is oscillation. Simple. And you have a simple pendulum here. A pendulum also does what? To and fro motion. We learned in the time chapter. To and fro. Yes or no? Here it goes to and comes back from. Like a pendulum, an oscillation. So that is called as oscillatory motion. And when it comes to vibration, what is vibratory motion, everyone? Vibration. Now wherever you have vibration, it is vibratory motion. So what is the speciality or the difference between vibratory and oscillatory? Simple difference is that in vibration, you can see, if this is a thread or a rubber band, let's say if you take a rubber band, pluck it in between, it vibrates, yes or no? Rubber band, pluck it in between, the rubber band vibrates. Then what happens? The shape changes, yes or no? You can clearly see. If I consider the different shapes, 1, 2, 3, 4 and 5, the shape of the object, the shape of the rubber band changes. You can also do this. You can place a scale, a steel scale, not a plastic scale. You can place a steel scale on a table, hold it here like it's fixed, hold it here, and you can pluck it. The scale vibrates, steel scale, not plastic scale, steel scale. Then also shape changes. So it's a type of oscillation because it goes up and down, to and fro. A type of oscillation, a kind of oscillatory motion in which the part of a body always remains fixed and the shape changes. What happens? Shape changes. It's a special type. Clear? Vibratory motion. Then you have periodic motion. Now what is periodic? Periodic will mean it will repeat after regular intervals. For example, here, I'll take the example of moon revolving around the earth. That's roughly 29 days. I mean, after 29 days, the moon again comes back to the initial position and again starts revolving. So here, if I say, for example, say, let's say the moon starts from here. Let's say this is the start point. The moon will again, it will go and again come back after how much time? After roughly 29 days. Roughly, okay. So if I just take a 29 days, so here the moon is regularly rotating around the earth. Revolving around the earth. So that motion is repeating, yes or no? It completes one circle, it will again repeat, again repeat, again repeat. So it is repetitive. It repeats the same motion, and whenever any motion is repeated, the same thing is repeated, we call it as periodic motion. Motion which gets repeated after a regular interval of time. Examples, many examples we have. Motion, moon around the earth, moon revolving around the earth, earth revolving around the sun. Motion of pendulum, it's also periodic. Yes. And one more thing, one more interesting one, what is that? Heartbeat. Our heartbeat is also periodic. Yes or no? You can feel it. Obviously, when you are not suddenly start to run or in a way, you're not doing anything physical, you're just lying down, you're resting. In that case, your heart beats at a regular time. Right? So it is what? It is periodic. Your heart beats. Repeats. Your heart repeats its beating. Your heart never stops, right? It repeats, keeps on repeating. That's the interesting thing. So it's a periodic motion. Some examples, as you can clearly see. A simple pendulum is periodic. It repeats the motion. Heartbeat, you can clearly see that. The motion will be repeated with time. Yes or no? So all of them are periodic motions. The motions is repeated. The same motion is repeated again and again and again and again. Clear? Okay. Now combination of motions. What does this mean? Now this animation shows that to you. Here it is rotation. The wheel is rotating there itself. Then the wheel is translation. Now it's in translation. Just moving. But when you combine them, it rolls. Rolling will mean what? It is going forward, translation, as well as rotation. You combine them and you get rolling. What's the animation again? Don't worry. So here it shows rolling. It'll again come back. Don't worry, it'll again be played. Now it starts. It's rotating, rotation, plus translation. Combine them, you get rolling. Understood? Yeah, so when a body has more than one type of motion at the same time. Simple example. Right, so rolling motion is a combination of rotational motion and linear motion. I give an example of rolling. So rolling is a combination. That way we have other combination also. What are they? When Earth revolves around the sun, you can clearly see Earth is revolving around the sun. So what all different types of motion you have here? 1. Circular motion. Then 2. Is that periodic? One time of 1 year. What is the time? 1 year. What is 1 year equal to? 365 days. So, and 1 year is always repeated. Right? Earth keeps on revolving around the sun. Same time. Repetitive motion. This periodic motion. 3. See, you can clearly see, is Earth rotating? Earth is rotating, yes or no? Earth rotates about its own axis. So there is also rotational motion. So all these 3 are present when Earth is revolving around the Earth. All of them. That's why we say Earth rotates about its own axis and also revolves around the sun. You can see that clearly in regular intervals of time. It is a combination of rotational motion, circular motion and periodic motion. All those 3. Clear? Yes? Okay, chalo, that's interesting. Understood. So that's combination of motion. So now random motion. What is random motion? Now look at this. You have a honeybee, right? An interesting honeybee. It's cute, right? Now I'll just throw a animation to you and you tell me which type of motion is that. Look at that. The bee is moving. I'll again play it. It moved. I'll again play. 3rd time. Now which type of motion is that? Huh? It's completely random. It's not going along a straight line. It's not going in a circle. It's not rotating. It is not repetitive. Like it's not periodic. So which type of motion is that? Random motion. We just call it as random. No name for that. Random motion. Right? So these motions are completely random and cannot be classified. Classified in the sense we cannot say it is a type of. It is not a type of anything. Right? So it cannot be classified as any particular type of motion or their combinations in fact. You can't say that this is a combination of curvilinear or anything. It's completely random path. Okay? That is the reason. Understood? Okay. So let's go into a few questions then. Which of the following is a periodic motion? I'll give you 1 minute of time. 1 minute of time. So please solve it. Which of them is a periodic motion? Everyone. Which of the following is a periodic motion? You have options. And look at the options. Freely falling body. So imagine it. In fact, you can draw a diagram. A swinging pendulum, draw a diagram. Bullet fired from the gun, draw a diagram. Imagine it first. Imagine and then draw. And a flying kite. Imagine it. In 10 seconds more. So 3, 2, 1 and the bell rings. The time is up. What is the correct answer? The correct answer, by the way, if it's a periodic motion. So which is a periodic motion? A swinging pendulum is a periodic motion. Freely falling body, no. Or if you throw a body, it goes down. It doesn't come up again. If it comes up, it bounces back, but not to the same height. Yes or no? So that's not periodic. Then a swinging pendulum, obviously a swinging pendulum, it goes to, fro, like or left, right, left, right, left, right, left, right. It repeats again and again. So it's a periodic motion. Yes. Bullet fired from gun. Does it come back? No. Imagine that we are firing a bullet and the gun comes back. And the bullet comes back. Very, very dangerous. Doesn't happen, right? So if you fire a gun, the bullet just goes forward, goes away. That's it. Doesn't again come back. It's not repeated again. Yes or no? So bullet fired from gun, not repetitive, not periodic. Flying kite, not periodic. It's a completely random. You fly a kite completely randomly. Yes or no? Because it depends on you. When you fly a kite, it depends on your skill. It also depends on the wind. Just too random. Right? So here only the swinging pendulum is periodic. All the others are not periodic, by the way. Non-periodic motions. Clear? Okay, next question. The heartbeat of a normal resting person is in dash motion. Your options: rectilinear, curvilinear, periodic, or translatory. So again, how much time this time? I'll give you 30 seconds of time. Everyone, 30 seconds. Timer has started, so 30 seconds. The heartbeat of a normal resting person is in dash motion. Rectilinear, curvilinear, periodic, or translatory. What is that going to be? Ten seconds more. 5, 4, 3, 2, 1, and the bell rings. What is the correct answer? The correct answer is periodic. Your heartbeat is what? Periodic. It repeats after a regular interval of time. In fact, it's clearly given here, normal resting person. He's not running, he's not jumping. Simple. He's just resting. So what is that going to be? The heartbeat of a normal resting person is in periodic motion. Option C. Wonderful. Next question. Circular motion is a special case of what? Rotatory, translatory, vibratory, or none of them? What is that going to be? Again, 30 seconds, not more. Should be enough. 30 seconds should be enough, everyone. So 30 seconds more. So start. So what circular motion is a special case of what? Rotatory, translatory, vibratory, or none of this? Everyone, what is that going to be? 5, 4, 3, 2, and 1. The time is up and the bell rings, and the correct answer is what? Circular motion is a special case of what? Translatory motion. Because when a car moves on a circle, car moves on a circular path, the front end of the car and the back end of the car travel the same distance. That is the reason. Okay. I think this could be the final question. Let's see. So irregular motion of bodies changing the nature of motion frequently are called as what? Irregular motion. Irregular motion. Regular motion, it's called as options. Regular motion, random motion, linear motion, or none of this. A very simple one, very quick. Let us take only 15 seconds now. 15 seconds should be enough, yes? So I'll give 15 seconds of time with no bell now. So what is that going to be? Irregular motion of bodies changing the nature of motion frequently. Frequently will mean regularly. Okay, time to time. The time is up, by the way. Time is done. Okay. What is the correct answer? The correct answer is random motion. It keeps on changing continuously. Random motion. Understood? Okay, that's good. That's good. Wonderful. So that's it, everyone. That's it. So we had a wonderful class. Yes. To discuss the basics, all that you know, we just named different types of motion. Let's just revise them. Practice it once. Will be simple. Next class, we'll be discussing about distance and displacement. So thank you, everyone. Thank you.